Hello, this is Preston Pie, and I'm here to teach you about some radicals. Now, there's a good chance that in your math career you will have to use radicals. I can almost guarantee it. And you'll most use radicals probably when you learn about quadratic formula and whatnot, all that fun stuff. But I'm just here to teach you a quick and easy way that I learned this school year. So, yeah. So, I'm just going to give us a more simple problem. It's not going to be radical. What's the square root of 16? So remember, a square root is really asking you, what same number multiplies into this? Well, I'll pause the video, or you pause the video, and just think real quick, what gets you 16? Well, if your answer is 4 and 4, well, that's correct. So the square root of 16 is 4. Is 4 times 4 equals 16. But anyways, that's not radicals. So let's get into the fun stuff. Okay, now we run into a little problem when we have a square root of 8. Now, if you try putting this in a calculator, you'll get 2 point something something something. I don't know. You'll get a decimal ranging from 2 and 3, between the numbers 2 and 3. But anyways, so I'm going to show you the first step. So we put the 8 at the top here, right? And what two numbers multiply to 8? Now, the only two numbers that do multiply to 8 is 4 and 2. And if this isn't making sense, I'm sure as we go on, you'll start to see the pattern. So now what two numbers multiply the 4? Well, the first two numbers that multiply the 4 is 2 and 2. And we're not counting 4 and 1 because think about it. If we just did 4 and 1, we'd just go on and on and on and on. So what numbers multiply into 2? What two numbers? Nothing besides 2 and 1. But like I just mentioned, they would just go on and on and on. So we're done here. So you're probably looking at this like, Preston, how in the world does this make you get the radical? Well, don't we have a pair of 2's here. We could cross them out like this, cross them out like this. However, all that matters is we have the same number twice. So whatever numbers we cross out, we put on the outside of the square root. And whatever numbers left over, we didn't get invited to the party, we put inside. And yeah, this is the quick way of doing radicals. So let's do a couple more practice problems. Because it definitely does get a little bit tougher when the number gets a bit bigger. So let's try something like 120. So let's do what we did back the first step. If you know how, if you're starting to understand how to do this, understand the pattern, I highly recommend that you pause the video right now and solve it for yourself. But for those who aren't as confident in this, continue watching on. You'll start to pick it up the more examples I do. So let's see here. What two numbers multiply to 120? Well, there's actually quite a few numbers that multiply 120. We could do 620, we could do 1012, and others. Personally, I'm going to do 1012. It's the first thing that comes to my head. So what two numbers multiply to 10? Well, that's not 5 and 2. So we got that. And what two numbers multiply to 12? There's 3, 4, there's 6, 2, but I'm just going to do 3 and 4. So we have 3 and 4. And there's one more step we gotta do. What is 4 multiplying 2? Well, we know from last problem, 2 2's make 4. So let's do our little party trick. Our 2's here, they go outside the house, they're just chilling. But then we have a lot of leftovers numbers, because we can't pair 2 and 3, because they're two different numbers. So you're not great with multiplying. Well, actually, we'd put all these numbers in here. But you're going to say, Preston, there's more numbers in there. I don't know what to do. Well, we got to multiply them. So if you're not really great using mental math, multiplying, whatever, use your calculator. But for me, I'm pretty decent at it. So 2 times 5, that's 10. 10 times 3, that's 30. So that's going to be 2 on the outside with 30 on the inside. So we're going to do actually we can do a few more problems. So this is pretty new channel, as this is the first video. If anyone has any type of math they want me to try to teach them, or do video on is what I mean, I'll gladly do it. So, let's do, I have a good number in mind. let's do the radical of 19. Now, if anyone's been pausing videos, doing the math while they do this, I highly encourage you don't pause on this one, because you might be a little stuck and get a little frustrated if you try doing this one on your own. So, let's think. What two numbers multiply to 19? Well, I can tell you to think, but the only numbers that actually multiply into 19, two numbers that multiply into 19, it's just 19 and 1. And like I said, they'll keep them going on and on. So we actually can't break down this 19 anymore. So actually what just ends up happening is it's just 19. This radical 19. I'm sure in your math career you'll come to like problems when it comes to that. As long as you realize it's like that, you're not stuck there forever. 10 minutes like, what do numbers add to 19? I multiply into 19. But I'm going to give you guys another problem. I was wondering, like, I was kind of thinking of saving this for the next video as it kind of starts to cover a different topic. But what happens when there's a negative in the square root of 16? Now, stuff starts to get a little more tricky with negatives. You'll come across this with quadratics, and you'll probably come across it a lot when solving for square. Or solving using the squaring method. I can't remember exactly off the top of my head. So let's put this at the top. Got negative 16, but actually, we already know from last time, right, that, that 16 squared normally, that's just 4. But what happens when it's a negative, right? Well, it would be 4, except it's going to have a little I buddy, a little I pal. What this I means, it stands for imaginary. It's an imaginary number. It doesn't exist. Essentially what's saying, especially using this for quadratics, it's saying if this passes on a non-existent plane, an imaginary plane, it doesn't exist. Also, whenever we do square roots, we always put plus minus in front of it, although I haven't really been doing that in the video, but that's just something important to keep note of. So, something that 4i means, well, like I said, just means to pass imaginary number. I'll probably make a video going more into imaginaries. I just want to kind of cover the basics of what imaginary number is. So if you don't really get it in this video, don't really stress it out. I won't really cover it all that much. Let's do one more problem. So let's say we have 150 in the square root. Well, let's put 150 at the top. Like I said, multiple numbers multiply to 150. It does not matter what numbers you do. It doesn't. It really doesn't. Because you'll always end up getting the same result. Trust me, you can test me on that one, but you will always get the same results. Or the same end product, I should say. So, personally, like I said, if you are confident in this, pause this part of the video, do it, and try solving on your own. Get that sense of accomplishment, get that dopamine rushing through your brain. So the two numbers that multiply to 150, the first one then, is 15 and 10. So, let's do some math. So what two numbers multiply to 15? Well, 5 and 3. And 5 and 3 can't go into anything else besides 1. Well, it's 5 out of 10. We got 5 and 2. So, our 5s are going to go outside, take a break, while our 3 and 2, they're going to be chilling inside the house. So we got 3, times it by 2, put 5 outside, 6 inside. Yeah, that is the answer to this problem. So, this is where I'm going to end it here, guys. If you want me to cover other topics, please put in the comments, and I'll look into the topic if I don't know. But there's a good chance I'll probably know the topic, as long as it's not calculus. But anyways, this is it. There's other videos, Khan Academy, he does, I'm sure he's definitely done this. So there's other sites, other videos, if you still need extra help on this. But this is just me explaining the basics. Like I said, leave in the comment section what you want to see next. Have a good day, and good luck on any upcoming tests or quizzes.